The graph of the function f of x is shown below. Sketch the graph of the function g of x equals f negative 2 of x minus 1. Clearly label the coordinates of the new points a and b. So to start solving the problem, we want to look at the function g of x. And we want to interpret what the different numbers mean. We know the negative 1 here is going to cause a downward shift. We know that this 2 here is going to cause a horizontal compression or stretch. And this negative sign is going to cause a flip over the y-axis. So to figure out if it's a compression or a stretch, I use the technique called intervals. So we're originally between 0 and 4, because we're at 0 here, and we go all the way to 4. And we want to get x by itself, so we're going to divide everything by 2. We're going to get 0, we're going to get x, and we're going to get 2. So we went from a range of 0 to 4 to a range of 0 to 2, so we know that we have a compression. We also then have to take into consideration this negative sign up here. So we know that we're going to be between 0 and a negative 2. So when we start to graph that, we're going to be between 0 over here and this negative 2 right here. And we're going to take this function f of x, and it's going to be flipped over this y-axis here. So our b point is going to be at negative 2, 3 right here, and our a is going to be at 0, 3, so it stays pretty much here. Then where we cross the x-axis is going to be in between negative 2 and 0, which will be at negative 1. Then the only thing we have left to do is to take into consideration the negative 1 here, which we said was already a downward shift. So we take the points that we've made, and we're going to shift them downward a unit of 1. So we're going to go right here, and here, and then down 1. We'll get our function. And then it said label the new points a and b. So a will be right here. We're going to get 0, 2. And then b, which is right here, is going to be at negative 2, 2. And that solves the problem we were given.